Hey, my name is Sanjay,
And my name is Will.
and our project will be based on a door closer. For the whole project, we'll be firstly giving you the information, and then we will be showing you a simulation of it using the program that we used. And then we'd be using the graphical analysis to find for the position, velocity, and acceleration values. Same using the analytical analysis. And then we'd be using the Newton-Raphson to find for the values. And finally, we will be concluding the project.
Here we can see a door closer and its typical functions. The first is to automatically close doors behind you, and this adds fire safety. This fire safety prevents fire and smoke from leaving a room. It also adds security for any kind of locked door. It allows the doors to lock behind you to prevent anybody from entering that you don't want. And lastly, the efficiency of the door allows for that temperature of the room to remain more constant instead of trying to disperse that across a whole area. Here we see a project simulation. This is close to, but not 100% accurate to the object we chose because the path of a door is more curved and this is a more linear back and forth motion. Additionally, the door frame limits the full range of motion of this mechanism. So this is a little bit more extreme of what the door is capable of.
So then now we'll be performing the graphical method to find the position of the mechanism. So we draw out all the links and then we measure the angles and then we find θ3 and the value of d. Next we'll be using the instant center and all the values given by drawing out everything, and then we would be finding for VAB, and then using VAB we find for omega 3, and then we set value of VBC as d double dot. And then we'll be using the same method but in a different way to find for the acceleration values. We'll be drawing out everything and then we would be setting values for AA plus, AN, ABA, and ABAT. And then using all the values, we would find for alpha 3 and the value of AB, which is d double dot.
Here we can see the analytical method. On the left side, we have all of our given values, which are A, B, the offset, and θ2, which we have 3 different values for, so that we did 3 different iterations during the analytical method. This sort of covered most of the mechanism's range. We also had omega 2, which was assumed based on how slowly the door closed, as well as alpha 2 was also assumed and a value that was chosen. On the right side, you can see the different values selected and calculated for. θ3 is broken up into points 1, 2, and 3 for each of the consecutive θ2 values. This goes for link D and solving for any of the other variables. We can see that while θ3 does not change much in terms of radians or degrees, the link values do. It's also noticed that omega 3 for all 3 values is fairly small, going to 0 for a 90 degree, and everything past that is negative, meaning it's going in a clockwise direction, with the exception of alpha 3.3, which is at the 90 degree θ2. At the very bottom, you can see the different equations used for this analysis. The top right would be for velocity, the bottom right would be for acceleration, and the bottom left would be for position. For the Newton-Raphson method, we used the Gaussian elimination and set our stop iterations when the difference between the delta x is 0.0001 or less. This is for the position analysis, as we saw for θ3 and d.
Next, we'll be using the Newton-Raphson to also find for omega 3 and d double dot. Also, using the same Newton-Raphson method, we could also find for the acceleration analysis using the equations given.
Here we can see the comparison between the different methods of calculation, analytical, graphical, and Newton-Raphson. And it's seen in the far right, we take the largest value of those three and subtract it by the smallest value of the three. And in every single category, starting with theta 3, d, omega 3, d dot, alpha 3, and d double dot, it is less than 1 unit of a difference between any of these values. This proves that it is a highly accurate set of data. For the conclusion, we have mechanism improvements, and we think that there are no improvements needed. This door accomplishes everything that it has been set out to do, and also comes with adjustable speeds if you want to increase omega 3 or alpha 3 or omega 2 and alpha 2. As for our analysis, it is seen that all three methods of obtaining values very closely agree to each other. This leads us to believe that we had a very accurate and very clean calculation and analysis. Thank you very much.